Ever wondered how data mining works? Imagine being a treasure hunter, but instead of sifting through soil, you're navigating through vast oceans of data. That's data mining in a nutshell. It's a process where we uncover hidden patterns in colossal data sets. It's a fascinating intersection of machine learning, statistics, and database systems. So, you might be thinking, how does one go about finding these patterns? The answer is clustering techniques. Dive into the heart of data mining with clustering techniques. A fascinating realm where data points converge and diverge based on their similarities and differences. So what exactly are these clustering techniques? Well, imagine a bustling city. It's teeming with people, activities, and places. Now, you're tasked with organizing this city. How would you do it? You'd probably start by grouping similar things together. The residential areas in one section, the commercial districts in another, and perhaps the parks and recreational facilities in yet another. This is essentially what clustering techniques do in the world of data mining. They're a form of unsupervised learning, a category of machine learning techniques. Clustering involves grouping data points based on their similarity. In theory, data points that are in the same group should share similar properties or features. Think of these as the common traits that bind your city's residential areas together. Perhaps the presence of homes, schools, and families. On the flip side, data points in different groups should have highly dissimilar properties or features. These are the stark differences that set your city's commercial district apart from its residential areas. Think office buildings versus homes, businesses versus schools. In essence, clustering techniques are the city planners of data mining. They organize vast amounts of data into manageable, meaningful groupings, making sense of the chaos. Now, let's delve a bit deeper, shall we? Let's understand the types of clustering techniques. There are several types of clustering techniques at our disposal. Let's start with partitioning methods. These techniques construct various partitions and then evaluate them by some criterion, such as minimizing the sum of the squared errors. A classic example is the k-means algorithm, where k represents the number of clusters. Next up, we have hierarchical methods. These techniques create a hierarchical decomposition of the data based on some criterion. They are either agglomerative, where data points are grouped using a bottom-up approach, or divisive, which is a top-down approach, where all observations start in one cluster and splits are performed recursively. Then we have density-based methods. These algorithms define clusters as areas of higher density than the remainder of the dataset. Objects in sparse areas are usually considered to be noise and border points. The key feature of these methods is their capability to discover arbitrary shaped clusters. Last but not least, grid-based methods. These techniques quantize the object space into a finite number of cells that form a grid structure. All of the clustering operations are performed on the grid structure, which is typically significantly faster than traditional data-based techniques. Each of these methods has its strengths and weaknesses, and the choice of which to use often depends on the specific characteristics of your data. With these techniques, we can effectively mine data to find patterns and insights. So, what have we learned today? Our journey through data mining and clustering techniques has been one of discovery and insight. We've seen how data mining isn't just about digging through data, it's about finding the hidden gems, the patterns and relationships that can help us make sense of the vast oceans of information we're swimming in every day. We've explored the world of clustering techniques, a set of powerful tools that help us organize that data into meaningful, manageable groups. We've seen how these techniques can reveal the hidden structures within the data, showing us connections and patterns that might otherwise go unnoticed. From the simplicity of partitioning methods to the intricate designs of hierarchical clustering and the flexible adaptability of density-based clustering, we've seen a range of approaches, each with its unique strengths. We've learned that the choice of clustering technique depends on the nature of the data and the specific insights we're seeking. We've also taken a deep dive into the key types of clustering techniques. We've seen how each type has its unique approach to grouping data, from hard clustering that assigns each data point to a single cluster, to fuzzy clustering that allows data points to belong to multiple clusters, and model-based clustering that uses statistical models to identify clusters. And there you have it, a crash course on clustering techniques in data mining. Until next time, keep diving into the data.